Hello and welcome back. In today's video we're going to cover circles and ellipses as they are tested on the ACT math section. These are generally going to be on the later part of the math section because they're one of the harder topics. As always, if you find this helpful, leave a like, support the channel if you'd like by subscribing, and leave a comment with any questions that you might have or things that you like or something you'd like to see more of. But let's get right to it. So what are you going to have to do on the ACT as it relates to a circle or an ellipse? One, you might have to match a circle or ellipse equation to its graph or vice versa. So you're either going to be given the equation and you have to pick the graph, or you're going to be given a graph and you have to pick the equation. This also includes inequalities, so I'll cover both the regular equation and the inequality version. The other thing you might have to do is use your knowledge of graphing circles or an ellipse to answer questions such as the number of intersect or overlapping points between two circles or two ellipses, or a circle and an ellipse. So let's start with circles. Here is the general circle equation. So the key things to note here, this has to be a plus, whereas these can be either plus or minus. So I have them written here with a minus, but it can be either one, and you can mix and match. That's fine. So what are all these? R, this over here, is the radius of the circle. Now notice it's r squared. So if they put something like, say, 3 squared, the radius is 3. But keep in mind, they're not always going to put it in this format. They might just put 9. If it's not something squared, take the square root of it, and that will be the radius. So that's what this warning is here. So again, if it doesn't have something squared, take the square root, and that's the radius. So here's the example that I was just talking about. If they gave you this with a 9 over here, instead of 3 squared, these are the same thing. The radius is 3, not 9. So that's R. A and B give you the center point of the circle. But remember how these can be plus or minus? That matters in choosing whether these are positive or negative. You want to use the opposite of the operator in parentheses to determine if A and B are positive or negative. So, as an example, if we have x plus A, if the A has a positive, then I want to use the opposite and make A negative when choosing where the center is. And when I have y minus B, I'll use the opposite and B will be positive for its center. So that's the circle. How would I then go and match a circle graph and its equation? So if you're picking an equation, start by eliminating any of them that just aren't even the correct form. So if they have x minus a or y minus b and don't have that squared, because remember here, each of these parentheses would be squared, or if they have this minus here instead of a plus, because while these two can be minus or positive, the one in between the two must be positive. So if any of them are in the wrong form, you can get rid of it immediately. Now, keep in mind, if they flip it and have the y minus b over this part and then x minus a over here, that's fine. I've never seen them do that. But since they're being added, you can be in whatever order you want. So next, once you have gotten rid of just flat out wrong equations, I usually start by looking for any that have the correct center. So I use my a and b here. Make sure you flip your signs to figure out which one has it in the right center. So A is going to determine the x value. Again, that's the opposite sign for x, whereas B is going to give you the y value. Again, also opposite sign of the operator of that with the y. Once I have the correct center, then if there's multiple choices still remaining, I can go and use the radius to figure out, okay, which one is the correct one by counting the distance from the center. Just make sure that the right side of the equation is in the r squared format, like I had said in the previous slide. If it's not, take the square root to figure out the radius. Now, if you're going the other way around and picking a graph, you'd do the same thing. It's just, we'll do it in the same order. You're just picking a graph this time instead of picking the equation. It's just that time you won't have a, okay, well, let's get rid of any incorrect equations because they would have given you just one equation. So let's look at an example. So here I have x minus 4. squared plus y plus 2 squared equals 9. So if we go through them, starting with the center is going to be at 4 minus 2, because I'll use the opposite sign of here for 4. That gives me the x point. And the opposite of 2 would be negative 2. That gives me the y point. So that's my center. The radius will be the square root of this, because it's not something squared, so it's 3. Sorry, I keep using 3 and 9 as my example. I'll switch it up some later, but that's just an easy one. So this is what I'm looking for. So if I go to my center, I'm going to go 1, 2, 3, 4, and I'm going to go down 1, 2. This will be the center, and the radius has to be 3. So from this center, I go 1, 2, 3 to find the edge of the circle. This is what I'm looking for. So now let's go look at an ellipse. It's very similar, but a little bit more complicated. So here's your formula. Now, just like with the circle, this here has to be a positive, but in the parentheses with the a and the b can be either positive or negative. The same rules are going to apply there for finding your center. What's new here is you have to have a 1 over here on this side. And obviously we've got these denominators now. But if you're ever trying to pick an equation and we don't have 1 on the other side, that's incorrect. It's not the ellipse. So this Rx, this new term here, that's the radius of the ellipse in the x direction, left and right, because this is an oval. That's what an ellipse is. So it's not going to have the same radius all around. So we're just going to find the x direction, so the left and right from the center to the edge is Rx, and then Ry is going to be the distance up and down from the center to the edge. Other than that, it's the same rules that apply for the circle. So again, a and b is going to give me the center, and again, we're going to use that opposite of the operator in parentheses to determine if they're positive or negative. So let's look at an example here. So first, let's start with the center. Again, I'm going to go to these parentheses, use the opposite. So for the x, I have a plus 6, so minus 6 will be my center. For the y, I have minus 1, so a positive 1 will be my center. And now, instead of having one radius, I'm going to have an x radius and a y radius. So the x radius, I'm going to go to this term, and remember, it should be something squared. So I have to take the square root here, since it's not in that format. The x radius is 2. Then the y radius, the thing under y, is going to be 3. Again, I go back to my 3 and 9 example. But if it's not in the something squared format, I have to take the square root. So what's this look like? I'll go over here, find the center. 1, 2, 3, 4. Well, 1, 2, 3, 4, 5, 6, if I could actually count properly. And then up 1. So I put the dot here to help us count the distance from the center, unlike the circle, just because it's a little bit funkier. So if my x radius is 2, then I just go 1, 2 to either the left or the right, and that's my x radius, whereas the y radius is 1, 2, 3 up, or 1, 2, 3 down. So that's what I mean when I'm talking about the x radius, that's this distance, versus the y radius, which is this distance. So that's an ellipse. So remember how I said you might have to say how many times they intersect or overlap. Here's an example of what that might look like. At how many points do the following shapes intersect? And they just give you two equations. And choices are 0, 1, 2, or 3. So how do I do this? We'll solve this over the next couple slides. So, first thing you're going to want to do is just draw a rough graph. You don't have to be an artist, it doesn't have to be perfect, but just draw a very rough graph and just put a dot for the shape's centers. So start by just finding the center of each of these. And what you're going to find is every time I've done this, and they kind of have to in order to make them easily solvable within the time frame. I can't guarantee they won't make an alternate version at some point, but I've always seen to do this is the centers are always going to be directly next to each other or directly above one another. So there's not going to be any diagonal going on here. They're either going to be left and right from each other or up and down from each other along a line. And that's very, very helpful. So then, along that axis that they're both sharing, so if they're left and right of each other, then I'm going to go and use the radius to draw a dot, a curve, whatever shape you want, to mark the edge of each shape in between each other. So I don't have to draw the entire circle, the entire ellipse. I only have to figure out how far does it go in the direction of that other center. And I'll give you examples of the 3 scenarios of this in the next few slides, so it'll be easier to follow once you actually see what I mean. But once you've done that for both of them, if their edges never meet, the answer is 0. They never intersect. If they meet at the exact same spot, the answer is 1, meaning they just touch each other and then bounce off. So they intersect one time. But if those 2 edges cross at any point, then the answer is 2, because they have to cross twice to complete the circle. So let's solve this and show what I mean. So here's just a rough axis. You could also have y, it doesn't matter. But if I look at this, drawing my rough graph and put a dot of the shape centers, here I have, for this one, positive 1 for my center for the x, and then there is no y plus minus anything, meaning it's plus 0 or minus 0. In other words, it's going to be right on the x-axis. Y is going to be 0 for my center. So for this one, plus 1 for the x and 0 for the y, that's its center. Whereas this one, it's plus 6 for the x, and again, y is 0. So that's 1, 2, 3, 4, 5, 6. Here are my 2 centers. Now notice they're directly left and right from each other. Like I was saying, they'll be left and right, or they'll be up and down. But you're not going to have one here and then one over here. That gets way more complicated. So next, along the axis that they both share, so I don't care about finding their edge over here or up here or around here. I only have to worry about this spot in between them. So now I have to figure out the radius for both to draw, and I just use a little curve typically, but you can do whatever you want to mark them, and find what the edge is for each in between each other. So let's again start up here. The radius on this one, which I have in red, so I have 4, but remember it has to be something squared, so it's 2 as my radius. So 1, 2, I put a little red curve, meaning it just goes this far. Again, I don't have to go and go 1, 2, 1, 2, 1, 2. I only care about in between the 2 centers, so right here. Then for this one, the radius is going to be 3, because 3 squared gives me 9. So from here, 1, 2, 3. Notice they both got to the exact same point, so my answer is 1. They just touch and then bounce off. They only intersect one time. So that's all there is to it. If you know what you're doing, you don't waste time drawing an entire circle. Or same thing if it's an ellipse. I just use a circle as an example because it's quicker, a little bit easier. So here's the other 2 scenarios. So let's start on the left here. I again have x minus 1 and x minus 6, so it's the same 2 centers, but I changed the radius. So for this one, the red, the radius is going to be 4, because square root of 16 is 4. So 1, 2, 3, 4. That's the edge of the red. And this one, the green, the radius is still 3. So again, 1, 2, 3. Now notice, they've crossed each other. So my answer has to be 2, because if I was to draw this out, it would have to go something like this, and then something like this. So it would have to cross somewhere up here and then somewhere down here. Meanwhile, over here, again, same centers with the x minus 1 and x minus 6. But the radius is going to be 2, so 1, 2. And in this case, it's going to be 1, because the square root of 1 is 1. So it's going to be here. So in this case, they never touch and never cross, so the answer is 0. So I'm just going to have a little circle over here, a little circle over here, and they never cross. Those are your only 3 scenarios. In your math class, they're going to say there's a 4th scenario where it's an infinite number of intersections, and that's just if you have the exact same equation twice. But I've never seen the ACT do that because that's very simple. But just in case, that is another scenario. So now I want to finish up talking about inequalities. Now in this case, the same rules for the inequalities are going to be applied to both the circles and the ellipses. So I'm just going to use circles for this video, just because it's a little bit faster. So, if I was to rewrite the general circle equation as an inequality, I'm going to have 4 possibilities. Now, before you get too confused, all I'm doing here is replacing this equal sign with a less than, greater than, or less than or equal to, or greater than or equal to. That's all that changed. So, how does this change your graphing? Well, to begin with, for less than or greater than, so no or equal to's, the circle is going to be drawn, or ellipse, with a dotted line. If you have an or equal to, then you need to draw it with a solid line. That means that the actual value of the line is included, whereas the dotted means the actual edge is not included. The next thing you have to do is figure out where to shade it, because remember, for an inequality line, you shade either up or down from the line. Well, in this case, I have a circle or an ellipse, so there's no up or down. It's inside or outside of the circle. So for less thans, or less than or equal to, you're going to shade the inside, whereas the graters and greater thans, you're going to shade the outside. Now, it's really easy to mix these up, so there's a really simple test to figure out which side do I shade. Just plug in the point 0, 0. If that makes it true, then whichever side has 0, 0 has to be shaded. So if 0, 0 is inside the circle, you're going to shade inside the circle. If 0, 0 is outside the circle, you'll shade outside the circle. The opposite is true if you plug in 0, 0 and it makes it so the math is incorrect. Then you want to make sure you shade wherever 0, 0 is not. So I'll show you two examples of that. So let's look at this first example. Here I have a circle as an inequality. So we'll go and graph it just like we would any other circle. Start by finding the center. So that's going to be -6 for the x point, +1 for the y point. The radius is going to be 4 because the square root of 16 is 4. Then I see I do not have an or equal to, so I have to draw this with a dotted line. The last thing I have to figure out is where do I shade, inside or outside this circle. So I'm going to use that 0, 0 test. If I plug in a 0 for x and a 0 for y, this is what I get. So the zeros go away, and 6 squared is 36. -1 squared, with the -1 being in parentheses here, becomes +1. So 36 plus 1 less than 16, or 37 is less than 16. That's not true. 37 is not less than 16. So 0, 0 cannot be in the shaded part. So what's that look like? Looks like this. I go over 6 and up 1 to find the center. I go 1, 2, 3, 4 to get my radius. So that's correct. Notice this is drawn with a dotted line. And if 0, 0 is over here outside the circle, I know 0, 0 is not true. So I have to shade inside the circle so I don't have the 0, 0 shaded. So now let's go and look. Here's the same equation, but instead of a less than, I have a greater than or equal to. So again, I have the same center, same radius, but now I have an or equal to, so I need to draw this with a solid line. And if I go do my 0, 0 test, I end up with the same situation, but now I have 37 is greater than or equal to 16. That is true. 37 is greater than or equal to 16. So now, since 0, 0 is true, it has to be in the shaded part. So I again have the same circle, but now it's a solid line, and I'm going to be shading outside of the circle because I need 0, 0 to be included in the shaded part. So that's all you're going to have to know for circles and ellipses for the ACT. Hopefully you found this helpful, and I'll see you on the next one.